Good morning to another person here. Myself, T. Muthukumar, Assistant Professor, Kongunadu College of Engineering and Technology. Today, I am going to deliver a lecture on basics of operational amplifiers in linear integrated circuits subject. So, operational amplifier. So, it is one of the amplifier circuit which typically has very high open loop gain and differential inputs. The gain of the open loop operation amplifier is very high. The inputs are differential inputs. So this op-amp generally called as gain blocks in most of the circuits. So they are used in so variety of applications due to their versatility. The gain, bandwidth, and other characteristics can be controlled by the feedback flow on external circuits. So this is called the gain block. It is used to improve the or amplify the power levels of the input signal. The linear integrated circuits are being used in a number of applications such as audio and radio communication, medical electronics, instrumentation, and control. So these are the applications of linear integrated circuits. Mostly they are used in communication purpose. That is audio and radio communication, and some medical applications are there, medical electronics, instrumentations, and control systems. We are using operational amplifiers. So this integrated circuit generally is called operational amplifier, introduced in the year of 1940s. The popular op-amp IC 741 was developed between the years 1964 and 1968 by Robert J. Welder at Fairchild Industry. So he is the one of the initiator of the IC 741. So this IC 741 uses the BJT and FET fabricated along with other components in a single chip of silicon. So it is made up of a single chip of silicon. So it is a multi-terminal device that has a complex internal circuit. So it has so minimum 8 terminal, 10 terminal, 14 terminal, different configuration pin terminals are available based on the packages. So it is a multi-terminal device that has the complex internal circuitry. So the operations of the, that is the performance of the op-amp can be determined by the terminal characteristics and what are the components externally connected to the particular terminals. So performance mainly depends upon the terminals of the operational amplifiers. So this is an integral part of all electronic circuits and work even in low voltages. So its cost is low due to the bulk production. So it has more advantages. So due to the low cost, small size, versatility, flexibility, the dependability of op-amp. So they are used in the fields of process control, communication, computers, and measuring devices. So it has the more advantages. Mainly the cost is low, size also small, so flexibility is available. So based on these characteristics, we are going to use the power process control, communication, and the computer and the measuring devices for this operational amplifiers. So next, so we are going to discuss symbol and the basic terminals of operational amplifiers. So it consists of two input terminals. So one is inverting terminal. There is a negative terminal. So inverting input terminal. So negative sign indicates the inverting terminal. Where positive terminal. So positive terminal indicates the non-inverting terminal. So these two things are the input terminals. We are going to provide the differential input to the operational amplifiers. So next one is the power supply connections, VCC. So we are going to provide the fixed DC voltage VCC and also minus VE for the pin numbers of 7th and 4th respectively. So last one is output terminal. So mostly 8-pin package means so 6th pin is the output terminal. So input and output are in antiphase having 180-degree phase difference. So we are giving the inverting input terminal to the negative sign of the terminal, non-inverting input to the positive sign of the terminal. So output is, so 6th pin we are getting the output. The input and output are antiphase having the 180-degree phase difference. power supply connections. So basically, we need to provide the to DC power supply. So plus VCC, that is V plus terminal. So we are going to connect V plus terminal to the positive point of the power supply. So here we are going to use the 215 volt regulated power supply. So positive terminal is connected to the V plus. So next V minus is connected to another DC source of negative terminal. So first DC source negative terminal and the second source positive terminal is connected to the ground. So we need to provide the plus VCC and minus VE. So generally, so the typical voltage range or power supply range for the operational amplifier varies between the plus 5 volt to plus 22 volt. So commonly we are using plus or minus 15 volt or plus or minus 12 volts. Packages. So three different packages are available. So one is the metal can TiVo package. So another one is a dual inline package, a dip. Third one is flat package. So these are the three different types of packages for the operational amplifier: metal can package, dual inline package, and the flat package. So these three different packages having different pin terminals. For example, it has 8 terminal TiVo or tip type packages are available. 10 terminal flat package also available. 14 terminal dip or flat package also available. So commonly, so we are having the 8 terminal APAM, 10 terminal APAM, and the 14 terminal APAM. So the popular IC741 so consists of single APAM and available as 8 pin dip or can package or 14 pin dip or 10 pin metal can package. So here we are going to provide the dual power supply connections for the plus VCC and minus VE. So commercially we are using the plus or minus 15 volt or plus or minus 12 volt for applying the supply. That is VCC and minus VE. So these are the pictorial representation of the pin configuration. The first diagram shows TiVo package, pi style package with the straight leads. So these having the straight leads of pins. So this is the 8 pin metal can. So 8 different terminals are available. So first pin is called offset null. Second is called inverting input. Third is called non-inverting input. Fourth one is V minus. Fifth one is offset null. Sixth one is output. Seventh one is V plus. So we are giving the plus V CC to 7th pin and minus V to 4th pin. So inverting input terminal is 2, non-inverting terminal is 3, output terminal is 6. So next diagram shows the dual inline package. So it is a 8 pin configuration. So here also, so inverting input is 2nd pin, non-inverting is the 3rd terminal, output is a 6th terminal. So we are giving the plus VCC to 7th pin, minus VCC to V to 4th pin. So 8th pin is no connections. Pin number 1 is offset null, 5 also offset null. We are giving the offset voltage between the 1 and 5 in this package. So this is dual inline welded shield ceramic package. Yes, consists of 14 lead dual inline package, 14 leads. So this is ceramic flat package. This is the 10 lead flat pack. So it has the 10 terminals. Here 3 and 4 are the input terminals, 7th is the output terminals. So generally we have the 8 pin configuration, 10 pin configuration and 14 pin configuration of ICs. So these are the different manufacturers. The famous manufacturers of the APAM ICs, Fairchild. So the initial APAM are MUA or MUAF, National Semiconductors, Motorola, RCA, Texas Instrument, Synetics. So these are the famous IC manufacturers. Some linear ICs are available at the different versions like A, C, E, S, and SC. For example, IC741 has a different series: 741A, 741C, 741E, 741S, and 74SC, or different versions of the APAM IC741 family. So each and everybody have some specific applications. IC741S and IC741SC are military grade op-amps. So these are operating at the range of -55 degrees Celsius to 125 degrees Celsius. They have the better sleeve rate compared to IC741 and 741C. So it has the better sleeve rate compared to IC741 and IC741C. So IC741C is a commercial grade op-amp whose operating range is 0 to 75 degrees Celsius. So 741E and 741C are improved versions of the having versions of IC741 having the better electrical specifications. So these are the different IC manufacturers under IC741 family ICs. Next, I'm going to discuss the block diagram of operational amplifier. So it consists of the following stages. One is the input stage, one is intermediate stage, third level is buffer and level shifting stage, fourth one is output stage. So initially we are giving the input signal to the input stage. So it is a differential amplifier. There's two input and two output. So it is called dual input balanced output, dual input balanced output differential amplifier. So the characteristic of this operational amplifier, the stage of amplifier is it requires a high impedance to avoid the loading of sources. So the first stage, input stage, has high impedance, that is high input impedance to avoid the loading of sources. So output impedance is very low. So input impedance is very high, output impedance is very low. So in this stage provides the most of the gain of the amplifier. So this first stage provides the input stage provides the most of the gain to the operational amplifier. So this output is given to the intermediate stage. So this is also differential amplifier. It has two input and only one output. So dual input unbalanced output differential amplifier. So in this case, we are using the direct coupling method. So the DC voltage level at the output of the stage is well above the ground potential. So after the intermediate stage, the DC voltage level is greater than the above the ground potential. So this also provides the additional gain. So during this stage also we are providing the gain. So practically the intermediate stage is called cascade of amplifiers, that is multi-stage of amplifiers. So next, buffer and level shifting stage. So all the stages are directly coupled to each other. So input stage is directly coupled to the intermediate stage is directly coupled to the buffer and the level shifting stage, means the DC quotient level of the previous stage gets applied to the input of the next stage. So finally, so the DC level voltage increases well above the ground potential. So we need to maintain the ground potential below the ground potential. So this stage voltage says these DC voltages drives the transistor into saturation mode and cause distortion in the output due to clipping. So we need to avoid or eliminate this DC voltage level above the ground potential. So the buffer is usually an emitter follower. So whose input impedance is very high. So this prevents the loading of high gain stages. So it prevents the loading of high gain stages. So buffer and level shifting stage used to reduce the DC quotient value. So passes by the direct coupling of the different stages. So finally, output stage. The output stage must have low input impedance. So output must have low input impedance, large AC output voltage swing, and high current sourcing and sinking capability. So these are the characteristics of output stage required for the operational amplifier. So the should require low output impedance, large AC output voltage swing, and high current sourcing and sinking capability. So these characteristics can be obtained from the push-pull complementary amplifier. So this amplifier meets all the requirements of the output stage. So this stage also raises the current supplying capability of the operational amplifier. This stage provides the current supplying capability of the operational amplifier. So during the first stage, most of the gain is provided in the system. So it has high input impedance, so low output impedance. So this output is given to the intermediate stage. So this is the cascade of multiple amplifiers. So multi-stage amplifier, it is known as multi-stage amplifier. So in this stage also, we are providing the some gains. So next stage. So it is the output of this intermediate stage is going to the buffer and the level shifting stage. So in this stage, the DC coefficient level well above the ground is reduced to certain level. So finally, output stage this is given the large AC output swing characteristics and high current source and sinking capability. So this is happened by the push-pull complementary amplifier. Next, ideal operational amplifier. So it consists of two inputs. So one is V1, V2. So V2 is connected to non-inverting terminal. V1 is connected to non-inverting terminal. Here I1 is equal to 0, I2 is equal to 0. So this is one of the main characteristics of ideal operational amplifier. So input current I1 that's equal to I2 is equal to 0. So gain of the ideal operation amplifier is equal to infinity. So AOR open loop gain of the ideal operation amplifier is equal to infinity. So because input is equal to 0, so V0 by 0 is equal to infinity. Output gain is equal to V0 by Vi. Input voltage is equal to here also 0. So these are the characteristics of operational amplifier. So it draws no current at both the inputs. So I1 is equal to 0, I2 is equal to 0. No current draws from the input. So that the meaning is it has the high input impedance. That is the infinity input impedance. And no loading effect on the driver stage. So input impedance is high means so non-loading effect on the driver stage. So next, the gain of the op-amp is infinity. So because here input voltage V1 minus V2 is equal to 0. That is the differential input is equal to 0. So if the input is 0 means so output equal to infinity open loop gain. So AOL is equal to infinity. So ideal op-amp has high input in infinite in gain. The third point is the output is independent of the current drawn from either of the input terminal. Finally, output V0 is independent of the current drawn from the terminals, input terminals. So its output impedance is 0. The input impedance is equal to infinity. Its output impedance is 0. Hence, it can be able to drive the number of output stages. So the main characteristics I1 minus I2 is equal to 0. So it draws no current from the both input. So second one is gain is infinity. So V1 minus V2 is equal to 0. Third one, output is independent of the current run from the either of the input terminals. So these are the other characteristics of ideal operational amplifier. So it has infinite voltage gain, infinite input impedance, so 0 output impedance, so infinite CMRR common mode rejection ratio, infinite sleeve rate, 0 offset voltage, infinite bandwidth, 0 power supply rejection ratio. So these are the ideal characteristics of operational amplifier. So next, so I'm going to discuss so voltage transfer curve or VI curve of operational amplifier. So the graph is drawn between the output voltage V0 versus input voltage. That is the differential input voltage VD. VD is called differential input voltage. So by maintaining the gain as a constant, so we are going to draw the graph between so input voltage and the output voltage. The differential input is VD, output is equal to V0. So this was the voltage transfer characteristics curve of op-amp. So here we are going to discuss ideal voltage transfer curve. So ideal characteristics. So ideally the open loop gain of op-amp is infinity. So AOL is equal to V0 by VD is equal to infinity. So from this equation VD is equal to V0 by infinity, that's equal to 0. That is the differential input is equal to 0. So differential input is 0. So at this stage, the output voltage is always at saturation level, that is plus or minus V saturation. For example, 15 volts means plus or minus 15 volt due to infinite gain. So ideal operational amplifier has infinite gain. For this reason, so at the 0 difference input, the output voltage is plus or minus V saturation. So the curve will be in the straight line. So it is in the saturation level. So output will be saturated. That is available in the plus V saturation and the minus V saturation. This is for the ideal voltage transfer curve. So next, so practical voltage source, voltage transfer curve. So practically, so AOL is infinity per an half amp. So we are going to choose IC741. The gain of the IC741 is 2 into 10 power 5. So keeping the saturation voltage to be plus or minus 15 volts. So we are applying the saturation voltage to VCC and VEE plus or minus 15 volt. The gain is 2 into 10 power 5. So from this equation, we are going to calculate differential input. So V0 is equal to gain AOL into VD. So plus or minus V saturation is equal to, so 2 into, that is output is equal to V saturation. So 2V gain is 2 into 10 power 5 into VD. So from this equation, VD is equal to plus or minus 15 divided by 2 into 10 power 5. So we are getting the plus or minus 75 microvolt. So this is the differential input. So plus 75 microvolt to minus 75 microvolt, the differential input is varied. So whenever the input VD is varies between plus 75 microvolt and minus 75 microvolt, the output will be linearly varies with the input. So this portion shows. So in between plus or minus 75 microvolt, the output will be varies linearly with the input. This is the linear characteristics. So if the voltage exceeds plus or minus 75 microvolt, the output is saturated. So this portion shows that output is saturated. At the point after point A and B, the output is saturated. So this is a practical voltage curve. So finally, I am going to conclude this session. So operational amplifier. So this is one of the amplifier circuit which provides the very high open loop gain and so differential inputs. They are also called as gain, standardized gain block. So it is used in most of the electronic circuit due to the gain, bandwidth, and other control characteristics. So applications in the audio and radio communication, medical electronics, instrumentation and control. Most popular IC is IC741. So it uses the BJT and FET as fabricated along with other components on a single chip of silicon. It is a multi-terminal device, but it has the complex internal circuitry. The characteristics is depends upon the terminal of the operational amplifier. So it has more advantages. So low cost, small size, due to the flexibility. So it is used in the process control, communication, computing, and measuring devices. So these are the symbol of the operational amplifier. So inverting and non-inverting terminal, the plus VCC, minus VE, and output terminal. So inverting and non-inverting having 180 phase difference. Power supply connections. So here we are going to provide plus V to the plus 15 volt battery, minus V to minus 15 volt battery. So to power supply, we needed to provide the supply the plus 7 and the 4 pin of the operational amplifier. So packages, so 3 different packages are available: metal can package, dual inline package, and flat package. So these packages have different pin numbers: 8 pin number, 10 pin package, and also 14 pin package. So manufacturers: Fairchild, National Semiconductor, Motorola, RCA, Texas Instruments, and Synapse. So these are the famous manufacturers of ICs. And also IC74 has different versions are available. Each and every version has some specific applications. So this is the block diagram of operational amplifier. So it consists of input stage, intermediate stage, buffer and level setting stage, and output stage. So characteristics of ideal operational amplifier. So I1 and I2 is equal to 0. That is, it has the high input impedance. So no current runs between the input terminals. So and no loading effect on the driver stage. Second one is it has a high gain, that is the infinite gain because of 0 input. So V0 by 0 is equal to infinity. So high gain input. So V1 minus V2 is equal to 0. So output is independent of the current run for the input terminals. So these are the characteristics: infinite voltage gain, infinite input impedance, 0 output impedance, infinite CMRR, infinite slew rate, zero offset voltage, infinite bandwidth, and zero PSRR value. So voltage curve is a graph drawn between the input voltage VD versus output voltage E at maintaining gain as a constant. So for ideal purpose, ideal voltage curve. So at zero input voltage, so it will be saturated voltage. Output will be saturated, that is plus V saturation to minus V saturation. Practical voltage curve. So between the for ideal operation amplifier, for the case of IC741, so the gain is 2 into 10 power 5. So in this case, so VD is equal to plus or minus 75 microvolt. So input is varies between plus 75 microvolt to minus 75 microvolt. So for this particular voltage is region. So characteristics will be in linear. So varies with input linearly. After this value, so it goes for the saturation. So, thank you.